The goal of these first two videos is just to try to set up an integral that will find the area under a bowl. Now what I want is, we know we have this bowl that we've seen many times this semester. What I want to be able to do after the second video is find the volume of that part of the bowl that lies above the XY plane. Well, first off, we're going to find out that that one is actually a little bit too hard, so that's actually going to hold off for the second video. What I'm going to do is something a little bit simpler. What I'm going to do is take the bowl, and so you can see here, I just have a little Play-Doh model of the bowl, like this. I'm going to put it down like this, and not find the volume of the whole bowl. What I'm going to do is just take a chop, and we'll figure out how far to chop. We do know that if we go all the way to the edge over here, we've gone all the way over to 5, and here is all the way down to -5, and over here, that's at height 5, and down here, this is -5. What I'm going to do is I'm just going to take a couple chops. I'm going to chop over here at 4 and just get rid of it. I'm going to chop over here at -4 and just get rid of it. I'm over here, I'm going to go down to -3, and again, I'm just going to get rid of it. And then I'm going to go up to 3 and just get rid of it. Now it's very important that we realize the two things about this. Number one, if you look at this, you can see that the top really is just still the top of the bowl. What I've done though is I've made a little piece of Play-Doh fudge out of this, where the sides are nice and flat and I can get away with something I want. Now, if this was Calc 2, we would take slices. Now the slices there always looked like discs. Here I do want to take a slice. I do want to find the volume, but I don't want to actually revolve anything. I just want to take a slice of this one. So what I'm going to do, I think, is not chop all the way at 4 or -4 or 3 or -3. I'm just going to take a chop somewhere in the middle. Just a chop, and I'm not going to worry about that one. I am going to bring that one back. Yes, I'm going to take a chop of this one right here, like this. And what I want to do is just estimate the volume of this little piece right here. So I'm going to move the other pieces away, and I'm just going to analyze what I have here. What I have is something that's nearly the same on the top as it is the bottom. So if I want the volume of that whole little thing right there, so I have a volume of one slice. Now in general, we're not going to have to take slices this semester. What we're going to try to do is get a good procedure. So the slice, what does it look like? Well, it looks like flat on this side, flat on this side, flat on the bottom, and then it's got that piece of bowl on the top like that, and then it's got thickness. So I'm just going to add the thickness. Let's see here, so like this, and like this, and then it's going to come over here like this, and then come like this, and like this. So you can see that the volume of that is the volume of just the one Play-Doh slice. Now what am I going to do here? Since the front and the back are almost the same, I can take this and just put it flat down like this. And what I'm going to say is the volume of the slice is just going to be the area of the face times the thickness of the slice. Now by the face, I just mean this whole little thing here. The thickness was actually easier because what I did was I chopped it like this, and we had y going that way, positive that way, and this way. So you can see here that the thickness of my slice is just delta x. It's a small change in x. So that's what I'm going to get for my thickness. Now, how in the world am I supposed to find the area of this? Well, let's just actually add some axes. Yes, if I add some axes, yes, I know that, let's see here, this went up to, this was -4, and this was 4, and I have these chops that went like this, and I have the piece of bowl that went like that. Now, that was y goes from -4 to 4. That's right. So this is y, and this is z. And if I look at this equation, we chopped with basically x as a constant. So what we have here is the area under a parabola. And what I'm going to do for the area of the face is say, that's a Calc 1 question. I know how to find the area of that. It's going to be the area from -4 to 4. The equation of the parabola is going to look like 25 minus x squared minus y squared dy, like that. So that's going to be the area of the faces. Now they're not quite the same, but we know every time we do this in calculus, we lie a little bit and we say that the area over here is exactly the same as the area over here. So what I have here is roughly the volume of one slice. Now we're going to do the calculus thing and start chopping this up into lots of little pieces and adding up all the areas, all the volumes of all the slices. Now what that's going to give us is an estimate of the volume. Now why is it not exact? Because I lied a little bit. I said that the front face and the back face had exactly the same area, but they didn't. But if the thinner I make that, the less I lie. If I want to get the exact volume, we do exactly what we do in calculus. We take a limit. Now what limit are we supposed to take? I want the thickness of those slices to get tiny. Like that. So this thing right here is going to give me the exact volume of my little Play-Doh piece of fudge. But this is an integral. This is actually a Calc 1 looking integral, and here's why, right? This inside integral here, right here, yes? It's actually a function of x, because every time you put a different constant x in there, you actually have an area. So this here is a function of x. So I have a function of x times delta x. I'm taking the limit as delta x goes to 0 of the sum. That's actually an integral. And we know that when we take the limit of something like this, we know how to do this. Calc 2 hopefully beat that into us. Yes, we get an integral. Right? The delta x turns into a dx. The inside function stays exactly as it was, so I get -4 to 4. I get 25 minus x squared minus y squared dy. Now, what was dx? Well, x, even in Calc 1, was the location of the chop, and my x's went as far left as -3 and as far right as 3. So we can see that the volume under the bowl with the square sides, yes, actually winds up being what is called a double integral. Now, in the next little video, I'm just going to evaluate that integral so you see how to evaluate the integral, and then we're going to go back and try to find the volume under the whole bowl instead of the chopped up bowl.